All right. I think we have everybody here in the front. If you are on the back, please come to the front. Your participation is needed. Well, June 11th, great day today. Thank you all for coming tonight. So excited, as always, to have this full house. Great people here tonight. My name is Gabriela de Queiroz. Me and Cedric and Molly from Microsoft, we run this event monthly here at GitHub. It's called SF AI and Show and Tell. And funny, like you are probably wondering why Gabriela has a horse in her slides. When I was putting together the presentation that Molly helped, PowerPoint designer suggested this, and I'm like, oh my goodness, this is such a pretty picture. I'm going to use it, like even if it doesn't make any sense, but it was kind of like inspiring me. I don't know. So anyway, welcome. A few things before we start the conversation, the talks, and the panel. So first of all, if you don't want to miss other events, go to Luma AI Inclusive. Take a picture, scan the QR code, subscribe so you can get notification about all the events that we are running. There is another one on the 24th, AgentCon. There are several events coming, another one in July. Also, like Reactor, Microsoft Reactor runs a lot of events online and in person. I would recommend you to check it out because there is a lot that you can learn from the Reactor, and all the Microsoft folks and MVPs and even people outside Microsoft, they also share their knowledge on the Reactor channel. One ask for you all, this is built with a lot of love, dedication, and time. All these events are a lot of work to put an event together. So please share your love on the social media. Please take pictures. Please share, tag us on LinkedIn, Twitter, X, Instagram, whatever social media. This would be very helpful for us. And without further ado, I want to call the first speaker for tonight, which is Vamsi Pandari, the founder of ReasonOS.
Hello, everyone. I'm Vamsi Pandari, founder of ReasonOS. A little bit about me. I have over 10 years of experience being an engineering leader and individual contributor at big companies and small companies. I've seen multiple exits and IPOs. I've been working with AI systems for several years now. And ReasonOS was a problem that I was facing at every company I worked at. And finally, last year, I kind of got fed up and started building a tool. Before I share a little bit about what we do, can I take a quick poll about audience poll? How many people here are technical? Can you raise your hand? And any non-technical folks here, product managers? Perfect. Let me ask you guys a question. For the non-technical folks, does your company allow you to make code changes and ship it to production using any sort of AI agent, code services, or other tools like that? No? Yes? No? OK. Before I explain to you guys why that gives most of the engineers anxiety, let me kind of explain why companies need DevOps, right? Let's go through a typical dev workflow. Most engineers have Workstation and then their favorite IDE. I hope it's VS Code, since we're here at GitHub. But if not, that's OK, too. And then you guys pull code from GitHub or any other Git platform out there. When you're first getting started, your tech stack is pretty simple, right? Your entire code base is in JavaScript. Your front end, back end is beautiful. The same engineer can work on your across entire stack. It's lovely. But as you scale, your tech stack looks something like this. You're using multiple languages, multiple systems in place, and to manage all of this, you need a build system. A lot of times for most companies, it's a bunch of shell scripts, but sometimes you can actually use an open source build system like Bazel, Pans, and NX. And then you use that build system, you hook it up to your CI/CD, you have a bunch of YAML files, and once your CI/CD tests and builds your product, hopefully you have a server that everything gets deployed to. But as you scale, this stuff gets complicated too, right? You're using more than one cloud service. You probably need to use infrastructure as code, Terraform, and then you'll need observability to make sure that everything is working properly and you can iterate through the process. Now, this entire stack is super fragmented, even for a senior engineer. All of this will take weeks to set up locally. And if it's hard for a human to do it, this stuff is really hard for an AI to do it, which is why it's very difficult for companies to allow AI coding agents to be used by non-technical folks, right? So we faced this issue at our previous company. We were a startup of 3 employees. We were managing a code over 50 million lines, several services, fragmented infrastructure, and we needed to scale this and support our enterprise clients. So we designed a tool from the ground up that is designed to be more agentic by nature, and you can use it with a lot of AI tools. And this is what it would look like with the ReasonOS stack. So we're replacing your build system, your Terraform infrastructure as code, and you can use ReasonOS. You could either use our macro language that we built from the ground up, or for deterministic workflows, or you can just prompt it. So let's take a look at, this in action, right? So this is how simple it is. So in this particular example, I just cloned the repo. I'm seeding into the repo. I apologize, when I was recording this, I was typing really slow. But you can just run RBS run server, and then RBS will figure out what language, what repo that you're using, and it's going to automatically build it, create the virtual environment, and run it locally. So you can have your instant developer environment without all of the complex setups. And then, if you want to use RBS for more complex workflows, like training your large language model that needs to be run across multiple different nodes, you can just add a little macro command and add the number of nodes that you want to do. And RBS will automatically spin up those nodes, link the CUDA drivers to it, and when you run the same command, it'll start running the workflow. 0 setup, 0 time spent on DevOps. And it has all of the features that would take some DevOps engineers months to set up, like remote code execution, language server, long running jobs, remote cache. Everything here is YAML-less. A lot of times, you don't even need a configuration file, but if you want something deterministic, we have a macro language that's Pythonic, and so it's exponentially more extendable. So let's take a look at what the infrastructure layer looks like. So in this particular example, again, I'm a slow typer. I apologize. So let me see if I can just fast forward it a little bit. So in this particular example, I have an example Django project, and I prompted our agent to generate the configuration file. And then you can accept the changes. And instead of writing your configuration in HCL, which is what typically most people use, we have a macro language that you can define your configuration in. The cool thing about using RBS to define your infrastructure is it is multi-cloud by default, meaning you can use that same configuration. If you change the provider, it'll automatically pick, for example, this Kubernetes cluster macro will pick EKS if your provider is AWS, but it'll pick GKE if you want to use GCP. And the cool feature that it has is you can actually use both, and we can do the networking between the two, and you can have the same environment across multiple cloud providers. And if you really don't like what the default behavior of our macros, you can actually just simply create a new file in the repo, and it's Pythonic, so it's like writing Python. And you can extend any functionality you like as well. So putting it all together, when you have the infrastructure layer, the tooling layer, the context layer, and the observability layer, all working together, you can actually do something really cool, right? So in this particular setup, I was using a multi-region setup on my cloud system, and I was having a hard time connecting to the database in one of my services, and it looks like I had an overlapping subnet, and the AI was able to find it because of RBS, managing all of the resources, all of the resource graphs, and providing that context to the AI agents for you to be able to do some of these DevOps workflows. And a lot of times, these workflows are fixable by our agents, and that's kind of a really good example. And by default, any system that you provision through RBS, ReasonOS build system, is default SOC 2, HIPAA, ISO 27K audit ready. So that's actually really cool. So if you want to use us to get your big enterprise customer, this is very helpful. And so coming back to the question, what would the world look like when most of the code changes are done by AI? And I was actually talking to someone at Anthropic, and I asked them this question, and the answer I got from them is, if you can use AI, any AI agent in a workflow that can be instantly validated, it's always a good use case, right? So front end is really good use case for AI agents, right? Because AI will generate code, you can just run it, and you could see all the changes visually. But when you're talking about your backend, your databases, your entire infrastructure stack, it's hard to validate that, right? You actually need an engineer to do it. And so one of the features that we just launched, we call it Pop View. So in this particular example, my co-founder, Chris, who's sitting right there, was using Codex to make a change, basically telling Codex to add weather integration, right? And so this triggered a workflow with RBS, and we instantly created a dev preview, spun up the whole environment for every branch, and then visually showed the changes of everything that was done by the AI. And so you can actually see everything that's happening, and if your engineers like it, hopefully you can merge it and release it in production. And so that's a little bit about what we do, and I hope you guys liked it.
All right, thank you. Thank you so much. So we have a few minutes for questions. And I'll be passing the mic. If anyone has any questions here, just raise your hand, and I'll go and find you. Okay.
Is this open source?
It's not open source yet, but we plan to open source it sometime next year. Right now, we're working with a few of our enterprise customers, and we're trying to get it to version 1.0 or 2.0 before we open source it and we start engaging with the community.
Hey, Vamsi.
Yes.
I'm a finance consultant, so my question is going to be from that angle. But
yeah.
What do you think are the most applicable use cases? Like, where do you see this being utilized the most in terms of verticals, like B2B, SaaS, or such?
Yeah, so actually this is cross-vertical. A lot of use cases we get are companies that are trying to sell to government. One of our customers just won an RFP with the state of California, and they're not complied with anything. So it would have taken them like months to get, FedRAMP compliance. A lot of companies out there do audits, but they don't actually provision the infrastructure in a way where it's compliant. And so they're able to use ReasonOS to get that compliance. So that's one of the use cases that, of companies using us.
Any other question over here? We still have time for one.
My question is about memory, because project grow and evolve. Of course, you will have a lot of things that add on. Mm-hmm. So how do you make sure that the agent would keep the complete understanding of everything without getting lost or forgetting the details? Because I think that that's a big issue right now in AI. Mm-hmm. So it would be for complex projects at some point. So.
Yeah, I mean, this entire tool is built for your large monorepos, and that is one of the issues that you get is with memory. And the cool thing about RBS is it's not just designed to run locally on your machine. It's actually cloud native, and our entire stack is designed to run in a way where your local machine isn't doing anything. A lot of these workflows are done in the cloud. And the cool thing about running everything in the cloud without having cloud workstations is that we can do some creative optimizations on memory. We can load things into the model, and we can pass context selectively and to get the best desired output.
Awesome. Thank you so much. We are done with questions. We will move on, but he will come for the panel later. So
sounds good.
Be awesome. Thank you again. All right. So next speaker, I'm so excited. A friend of mine, ex-Waymo. You probably pretty much everyone here knows Waymo nowadays. If you are in San Francisco visiting, now it's a tourist place or car to go and try. So come to the stage, Brooke. Welcome. Thank you so much for coming here. And while she connects, I want to say something. So I don't know how she does, but she's in all events and conferences. I think I've been following Brooke in all the conferences. I've seen her talks several times, and it's always great. So I'm so glad that you are here. Thank you so much again. And you can use either one.
Amazing. Yeah, I do this 9 to 5, and then I code 5 to 1 a.m. So, hey everyone, I'm Brooke. I'm the founder of Coval. We are building evaluation for voice AI, so helping you to really test and productionize your voice AI applications. I was previously at Waymo. I led our eval job infrastructure, so the team that was responsible for all of our developer tools for launching and running simulations. How many of you guys have ridden in a Waymo? Nice. Yeah, it's pretty magical, and I think I definitely saw it go from not super magical to being very magical while I was there. And I think we're taking a lot of those lessons from how do you really productionize an autonomous driving agent, which is essentially just an agent on wheels, and apply those lessons to voice AI. You might be like, what is the relevance of self-driving with voice AI? There's actually a lot. So similar to self-driving, you have lots of models chained together so that you can produce an autonomous agent. That leads to a lot of the same problems around how do you get from point A to point B, how do you run simulations of all the possible paths, how do you operationalize agents to be able to both handle lots of new scenarios, but also be really reliable so you can deploy them at scale. So what Coval does I'm going to do more of a technical demo because it sounds like there's a lot of technical people here and really get into the weeds. But what Coval does is we run simulations for voice agents. So we'll go back and forth with your voice or chat agent and simulate all the possible scenarios that that agent might be in. So we, very similar, I think, to self-driving, will come up with a scenario. Like, what are we trying to test? This might be something like, you forgot your password and you're trying to reset your password. Or you're trying to do a customer service agent, et cetera. And so we will generate this conversation over here on the side. And one of the reasons why you have to simulate conversations is because unlike a lot of other traditional software engineering, you don't necessarily have this like set environment where there's an exponentially exploding possible paths. And so if you were to hard code every single part of that, you create these very brittle tests. And so what we do is because we are dynamically generating these tests, they're much more durable as your agent changes. And then we'll run a bunch of metrics on these. So we run audio metrics. We'll show you like the latency throughout your conversation, as well as helping you to avoid to create your own custom metrics so that you can say, what does it mean to be successful as this agent? Because I think something that's really cool about voice agents is that we suddenly have this ability to test agents because we've created this simulator that's essentially the best simulator of human language we've ever seen. And so all of a sudden, we're able to simulate all these possible scenarios that the agent might go through. I'm going to do something crazy that I've never done before, which is I'm going to create a voice agent here and then test it with Coval. So wish me luck. OK, so if you've ever heard of, does anyone here have an idea of what voice agent I should build? Name something. What did you say? SoundHound? OK, can you give me a description of what?
They're the technology that powers finite voice conversational AI.
OK, but let's go, I guess a specific scenario. OK, we'll do maybe a customer service or let's do something that tells us about GitHub. So we'll call it a GitHub agent. And this is going to be just it's going to tell us about it's going to gather some feedback about GitHub. And so this is going to be this is our agent. This is called Vapi. It makes it really easy for you to create voice agents. So you're welcome, Vapi, for demoing your platform today. So here you can see I created this agent. It has this prompt. And then we can deploy that agent to this phone number. So it's called Cameron. And now this agent is going to be at this phone number that I just created. And so what you would do if you wanted to test an agent like this is you would come into Coval and you would create an agent. And so I can paste in this prompt here just so that I can auto-generate a bunch of the stuff that I want to create. And then I'll come in here and get this phone number. I think something that's really cool about voice AI is that you have a universal API for interacting with agents because we have a phone number and natural language, which everyone knows how to speak. And so this is going to be GitHub info. And I want to edit this agent to tell me information about GitHub. So I'm going to just generate edit. OK. And then something else we can do is, so with Coval, you can generate a workflow. And that's going to be voice agents generally will go through a certain number of steps. So we can, for example, say like, okay, what are the steps that this prompt has? I haven't even read this prompt, but there's going to be a bunch of steps that it has in this. And so you can generate a workflow that then allows you to step through. That's going to look something like, that's going to look something like this. So it's going to be a workflow that we'll create, and then we'll connect that agent. And so now we can then create a persona. A persona is going to be like, how do we simulate that a user that it will talk to? We have a bunch of off-the-shelf ones, so you can just use those off the shelf. And then we're going to generate a test set for this. So I'm lazy, so I'll just generate a test set also. And I just pasted my prompt in there. And so a test set is going to be a list of scenarios that you want to test. So in self-driving, what we would do is say, like, I want to test like driving through an intersection, or I want to test like passing a car. In conversational land, what we'll do is we'll test like different user behavior. So like, like ask ask about certain features, ask me about like different capabilities that GitHub has, like what are the latest features that it's launched, etc. So you can think of this as basically like the like features of your agent of like, I want to go through these specific flows. I think something that people get wrong about agents in general is that you should be thinking about your evals as a part of your product roadmap. So it's not equivalent to unit testing in traditional software engineering, but you're actually using it as an exercise to really think through like, what are the capabilities of my agent? And so capabilities of your agent might be like, I know I want it to be able to do these things really well, because if you try to do everything, your agent will be pretty mediocre. But if you try and do one thing really well, you're always going to be better than, say, like a general platform like OpenAI with voice capabilities. And so I think this process of creating the test sets is one of the most critical pieces, is thinking about like, what are we optimizing for? Then the next step is that you're going to create some metrics. So it's like, what does it mean to be successful as my agent? You can create lots of different metrics here. Actually, something that's cool is you can create from here, you can also generate metrics and test sets based on the prompt that you provided. So we can create a metric which is like, did it answer the user's question? And I think here, answered. So here's where like this is like actually a pretty bad metric, because you should be really specific with your LLM as a judge. So something that we really recommend, and if you guys have built AI applications before and used LLM as a judge, you know that it has really varying results. You might end up with a dashboard that's just full of like lots of meaningless numbers. And so we think that one of the really important pieces of building metrics and LLM as a judge is actually iterating on that through like our metric studio or against a golden data set. So saying like, okay, I haven't run this metric yet, so there are no transcripts, but I can upload a bunch of transcripts that I know should adhere to this metric. And then I can run that metric on all of those transcripts to say like, how often is that metric correct? Okay, I don't have a good example of this because I'm doing it on the fly. But you could say, you could, for example, like select this transcript and then say like, did they ask about London? So this is probably going to be pretty accurate because that's like not that hard of a question. But then you can also run it multiple times to show like how deterministic is this metric. So I think trusting your metrics and looking at the data are both two really important parts of really good evals, no matter what kind of AI application you're doing, but especially in voice. Cool, so now that we've made all of those things, what we're going to do is then select, we're going to launch an eval. So here we'll launch an eval with our agent. Basically an eval is like an agent talking to a simulated user. So yeah, maybe I'll pick like a frustrated customer. They're like, what does GitHub do? I'm frustrated. And and then we'll collect this survey, et cetera. And then you can select a bunch of metrics. So for example, we can find my questions answered metric, et cetera. And then we can launch that evaluation. And so basically then that will run a simulation of all of these possible scenarios from that, and then I'll be able to see how those conversations panned out instead of having to call my agent over and over. And so this is like really why simulation is so important for conversational evals, or really agentic evals in general. We mostly focus on conversational, but being able to see how your agent pans out many turns in is really important, and being able to create static tests like that is going to be really hard. So this is very like similar to what we did at Waymo, which is really how do you can even start to take logs from production and then re-simulate those to see, okay, if I had taken these scenarios that I've already seen, is my agent now better or worse than those? So yeah, I think that will take a second to run because I should have run it concurrently. But you can already see that like some of the simulations are going to start to show up, and then you can see the progress here. So that's a super whirlwind of how you can set up a voice agent and then run your evals on it. I'm always super happy to talk about evals and eval strategy. I think it's definitely the most, like what we've seen creates really amazing AI products across the board. So yeah, let me know if you have questions.
All right. Thank you so much. I have a bunch of questions, actually, before I open to you all. Can you talk a little bit more about like these simulations? Like, how does it work? So I come from statistic background. So when we do simulation, it's like based on a distribution or something. But how does it work on the voice? So that's the first one. And then the second one, do you feel like we have a standard evaluation metric or a set of evaluations? Because I've seen being like binary, yes or no. What is your take on that?
Yeah, I think to the distribution question, this is where I think probabilistic evals are really important for agents, is you're not necessarily looking for how often, or like for this exact scenario, did I get exactly the right answer? You're looking for how often am I getting the right answer? How often am I doing the wrong thing? So for example, at Waymo, you're saying like, how often am I, stopping at the stop sign versus how often am I doing a hard brake? And the same is true with voice, where you're looking for how often am I resolving the user inquiry? How often am I apologizing too much or repeating myself or mistranscribing what happened in the conversation? So I think that's kind of to your point of like probabilistic evals and probabilistic simulations. The second question.
And then the second question is about the evaluation, the metrics. Because I see a lot of discussion about, like, is it binary? Should it be like interval? Like, it should be like, what is your take on all the discussion about the evaluation that we are seeing right now?
Yeah, I think this is actually a question we get a lot, is like, can you run your standard evals on my agent? And we cannot. Like, I think this goes back to like the product question of like, what are you trying to make your agent do? There's definitely a set of metrics that I think a lot of people use. For example, latency, interruptions. Is your agent pausing too much? Is your agent finishing the conversation? But ultimately, you're going to have a set of trade-offs for your agent. Like some cases, you care about latency because you're an outbound sales agent, and like how fast you get to the point and how realistic you sound are the most important pieces. But other cases, like medical inquiries or customer service refunds, it matters a lot more that your agent is accurate because the user is very motivated to get to the answer. And so I think every agent is optimizing for a different set of constraints, and so there's not necessarily a set of metrics. And I think that's also like, we started off creating, like we're a team of like CS people from Stanford and Berkeley, and we like went super down the rabbit hole of like, let's use all of the latest research papers out there to create the most advanced metrics. But it turns out that like actually creating really specific, simple metrics is better than creating really complicated off-the-shelf metrics. So I think it's really thinking like really hard about what does quality look like to you.
Cool, thank you. I'll open the floor for questions. Oh, there is one back there.
Sorry about this. Yeah, I guess my question is actually on edge casing. You know, I think, as you were saying, a conversation can kind of go any direction you want. So how do you handle edge casing? I mean, you know, in a GitHub customer success scenario, right, they could be asking a question about GitHub Actions or something. Does your tool help with generating the questions for edge casing, or is that something the engineer is going to have to develop themselves?
Yeah, I think definitely like ideally we are like auto-generating these edge cases. So we provide a lot of tooling for you to be able to identify like outliers, because we also do observability. So being able to run all these same metrics, but in production for live calls. So being able to flag this conversation was outside of distribution, this conversation is like weird in some way. But I think also creating really strong eval processes. So I think especially because agents, just like you're constantly discovering new use cases. If you've deployed agents in production, you know that like each agent is a little bit different per customer. And then also as the models get better, as the technology gets better, as your engineering team moves the agent forward, all of these things, there's like a constant process, and so evals should also be a process that you have on the engineering team. So how do you set up continuous monitoring? How do you set up a process for finding those edge cases and then adding them into a regression set? I think hill climbing sets are also a really useful thing. So a set of things that you know you're bad at, but you're trying to get better at, versus a set of things that you know you should nail every time, and so therefore they should pass every time.
So first of all, thank you. This was a great presentation. I guess my question is more of a clarifying question. So does Coval today, does it mainly focus on transcripts, or do you also evaluate the actual agent's ability to comprehend? So tone, pitch, is it understanding the customer? Is that part of the eval stack, or is it just the transcript?
Yeah, so we do both conversational, so like the transcript evaluation, then we also do audio analysis, and we also do tool call or like kind of everything behind the scenes analysis as well.
Gotcha. Okay. Thank you.
So I think different metrics make sense at different levels.
So you mentioned that your tool is mostly used for evaluation, but just as a parallel to Waymo, have you ever considered, or is it capable of data augmentation for some sort of offline training and fine-tuning of a different model?
Yeah, definitely. A lot of our customers actually use like simulations as for reinforcement learning, or for like path memory, somewhere in between reinforcement learning and just like optimization. So yeah, that's actually, I think, a super interesting space that hasn't been super explored either in the voice community.
So one last question before we go to the next speaker. Anyone else?
Yeah, I'm curious what type of customers you have right now.
Yeah, right now we serve like everyone. So last year we started, and we are basically only serving startups because those were the only people building voice agents. And in the past few months, I think now we have very large public companies, enterprises who are using us in order to build their voice agents. I think we've just seen an explosive growth in terms of who's building voice agents and like how fast they're deploying them.
Cool. Awesome. Thank you so much, Brooke.
Thank you so much, guys.
Thank you. All right, so our last speaker for the night, Ahmad from Langbase, which had last week at AI Engineer. I don't know how many people here were at the AI Engineer World's Fair. How many people here were at the conference? A few of you. So it was like one of the biggest, the best conference right now in San Francisco last week. And they had a booth, and their T-shirt was the best one. It was the only T-shirt that I was like, okay, I want to have one of these. So thank you so much for this T-shirt. Another question that I have for you all, which I forgot. How many here are like startup founders? Awesome. And how many here are not based in the Bay Area, are here visiting? Very cool. All right, the floor is yours, and this should work for you.
Awesome. Yeah, hello everybody. I am Ahmad Awais, and today I am going to be talking about a controversial topic, frameworks versus primitives. I've been told there's been a lot of debate going on my talk. I gave a similar talk on AI Engineering World Fair as well. So, and I know I'm the last speaker today. I promise to be brief, no matter how long it takes. Somebody got it. So. Okay, so who am I? I started my career building a lot of spec work. I've contributed to all sorts of things. If you are using React, JavaScript, WordPress, TypeScript, OpenAPI, Node.js, you are probably using some of my code. And I've written a lot of open source software. My open source packages are downloaded anywhere from 30 to 50 million times a year. I share this with you because I love building software, right? So I only have one question before I start. How many people here have built an agent and deployed one as well, like it is actually in production? Yeah, so that's my biggest fear, right? People, I think, especially developers, I feel like they're not building enough agents. And I was relatively young. I was building a lot of websites, right? Any idea we would have, we would build a website for it, right? I feel like there's a lot of confusion around the word agent. And today I'm going to try and address a bunch of it, right? I'm also a big fan of purple color, by the way. Thank you, GitHub, for tagging everybody with purple today, right? Okay, let's get started. So another thing you need to know about me is I don't like to travel much. I was traveling a lot in 2020. You know what happened. One good thing that came out of 2020 was I got an invite from Greg Brockman to check out their API. This founder of a new company that was a non-profit company. They're building some sort of open AI, right? And they were like, we are building an API on top of a model called GPT-3. Would you like to try it out, right? And what would you use? What would you think the use case for that would be? And I was like, I'm going to suggest next line of code, right? And from there on out, I've been building a lot of agents, as you can imagine. I've built things that have gone up to scale of 100 of million runs plus months every month, right? And that entire thing has become a company now. We are called Langbase. We are an AI primitives company. You can think of us like AWS for AI engineers, right? So just like when you need a compute or storage or database, you go to AWS and you get one, right? And they scale it for you. Like you need storage, you get S3 from them. You don't actually expect AWS to have a framework. You expect them to have API as an SDK, right? So that is what I think is what we are building. We have built a bunch of primitives that you can use to build any kind of agents. And most of the times, an agent ends up looking like this. You have some sort of an LLM. You have a thread store. A lot of people think that threads are used to maintain conversation, but threads are like a memory scratch pad, right? You can store any type of context in threads. All you really have to do is have a primitive called threads that can scale autonomously without you having to worry a lot about databases, caching, or this or that. So yeah, that is one of the primitives that we built. Then there's context. Context comes in a lot of forms, mostly prompts. And then there is memory. Memory is reasoning like we humans have. That is why we are here today, by the way. LLMs are basically self-attention algorithms. Self-attention is like if I were to ask you, which college did you go to? Maybe that was like 10, 20 years ago. Your brain will actually quickly get all of the context of your college and your time at that college, and you will start answering questions related to that. That, as an algorithm, was invented around 2017, 18 by some of the really smart people. And then they trained that algorithm on top of everything that is available on public, all the public data. This is the super simplified definition of what an LLM is, right? And now I see a lot of people are building frameworks. I don't think a framework can be built, right? I think you need to build your own framework. All you need to do is build, have access to primitives. Like if I did not have access to Postgres, I don't know what I would have done in so many companies that I used to work for, right? So, well, there's a lot of theory. Before I move ahead, I'm going to do something crazy here. And I'm going to start building agents that will be deployed right now in front of you. So anybody of you can also do it. It's chai.new. Chai is our product, computer-human AI. And Chai can build agents for you. It's a combination of 56 different models and an agent. And we are right now not selling it as an API because it requires a lot of infrastructure behind it. But it can build anything. It can understand what you're trying to build. So one of the most common agents we have seen. Chai is, by the way, 40 days old. And 104,000 agents have been vibe coded with Chai in just about a month. So one of the most common use cases we have seen is there's some data, and I want to talk to it, right? So there's some private data, right? So let's start with chat with PDF. Oh. And I totally expect things to break, right? So yeah, putting it out there. I'm also going to build something like, I don't know, a summary agent, which is very simple. I'm also going to build something like email agent. I think we have a template for that. There you go. So Chai is right now building all of these agents while I am delivering this talk, right? OK, so here are the very simple primitives that we have. So you have pipe, which is an OG standard of building agents like MCP. We have memory, which is per use case based vector store and a reasoning engine. So imagine you build reasoning around different topics and you build a bunch of RAG stores. What if you wanted to reason across those RAG stores, right? So the documentation of your competitor 1, competitor 2, and competitor 3, and you want to ask, do they offer this kind of thing, right? So that requires reasoning over multiple data stores, multiple vector stores in our case. You can very easily do that with memory. Memory is a serverless vector store, 30 to 50 times cheaper than Pinecone. And there are similar things like this, threads, agents, parse, or even a parse a PDF. All these are cloud primitives, right? These are AI primitives. Instead of building everything from scratch, we are hoping that people like yourself would start building agents very, very quickly using these cloud primitives, which are serverless and they autonomously scale, right? So the argument kind of becomes, at least in my head, like this, that the painful way of building agents is you pick up some framework with some obscure abstraction, which is extremely hard to debug. You are not really sure if the LLM is hallucinating or it's your framework, right? Or your code, or the environment you are building it with, right? And then you have to figure out how to deploy it, scale it, and kind of build a business on top of it, right? All these things we went over with when we invented, the web was invented, and hosting companies were created, then Stripe was built. We've gone through all of this, and now we are trying to reinvent this space for some reason that I don't understand. I think, here's my hot take, I think agents are just code. Agents are code. If you just replace the word agent, you will instantly feel at calm. It's a new way to write code, right? And if you were inventing a programming language to write that code, I'm all for it. But if you're building a framework, to me, it feels like AWS were to build a framework and say all of their 500, 600 primitives can be used by this framework. And then I know nobody will be able to use that framework, right? So these are just simple APIs and SDK, right? If you build with these composable AI primitives, cloud primitives, and they don't have to be our cloud primitives, my startup cloud primitives, they can be any primitives, as far as they are built for AI agents, right? So instead of using a database, you are actually building, like threads is a coordinated database problem. Every time you are adding something to a thread primitive, it is being written to two databases. One is being used to read. The other one is being used to write. so the write and read speeds are similar, so you don't have any coordination issues when you're doing tool callings, right? Stuff like this, right? Any agent you build on top of this becomes serverless, so it scales autonomously, and you get to enjoy what I'm going to do now, right? So Chai has gone ahead and done a bunch of things here. I'm going to go ahead and deploy it. I think we have our first bug. Yay. I'm going to deploy this one, and I'm going to deploy this one. Let's see, third time's a charm. Oh, I don't think I can deploy it for some reason. I'm probably going to go jump back to the agent that I built when I was just sitting here, right? So to make sure it works, right? OK, all I asked was, I want to chat with PDF, and it figured out everything around it. Chai, we built it because we wanted to invent what an agent interface looks like, right? We know what the agent code looks like, right? So what Chai has done right now is it has figured out, oh, you need space to upload that PDF, right? And that space should not be just object storage. It should be some form of vector database. You don't need to know that. It's going to use our memory primitive, which is exactly that. It's storage, but it's mixed with vector storage and a reasoning engine. And then it's figured out, we will build a simple agent that can talk to that vector store, right? And you can then ask any questions. So it has gone ahead and written all of this code. This is just those 3 lines that are responsible for that memory. You are retrieving data from those memories. It has created that memory right here. And it is telling us that, well, you can throw data into this memory using an API, right? But we can also drag and drop things here, which I have done, right? I've dragged and dropped my talks page from my website and my about page, right? And in there right now, in step 2, it has basically built an agent using OpenAI. It has prompt engineered it as well. You can basically select this, click improve, and ask it, can you switch to Gemini 2.5 Flash? And it will basically not only just swap the model name, but it will probably also change the prompt engineering, because all these LLMs expect different kind of prompts. And for the life of me, if you say not, or any kind of negation to Gemini Flash, it thinks it is supposed to not do anything, right? So yeah, never say no to Gemini Flash, right? So OK, it will prompt engineer all of this. It will build the workflow. All of this is editable. All of the code is right in front of you. You can edit and add more things to it. It is not a framework. You can do whatever you will with it, right? It has built a flow. I'm probably going to zoom this a bit. So it's basically trying to show you what this agent looks like behind the scene. It will use this memory to generate answers. It will start and ask questions from that particular PDF and throw that into a generate answer agent, right? I've thrown that files here. It has built me an API that I can use in whatever system I want, whatever language I want, right? And one thing it has done is it has also built me an agent app. Right now, it just looks like a chatbot, right? And I know we are all kind of sick and tired of looking at chatbots, but what I want to show you is that this UI is actually generated right now. So if I were building a different kind of agent, which I have in this particular scenario, where it built an AI email agent, right? The UI would look very different, right? In this case, what's happening is I wanted to summarize and analyze the sentiment of email, determine if the response is needed, compile the results, and then figure out if we need to draft a response as well. So it has gone ahead and created a bunch of different agents that are talking to each other, right? How about we just give it a go? Like we can ask this one, like, you won 100 million lottery, and see what it does. At the same time, I can go back to the older one. I can ask something like, I don't know, who's the founder of Langbase and what are his last 3 talks? Right now, this is a similarity search happening. So all these just 3 words, and we have this agent with the API, with the workflow, multi-agent code available for you, deployed on our platform, working out of this application that you can also, like, you can make it public and you can take this URL and you can bookmark it on your mobile or whatnot, right? The same thing here. You won 100 million lottery. Sentiment is quite positive, quite urgent, right? And it has gone ahead and responded to it. So I don't want it to do that, right? It tends to always do this when I'm presenting. Generally, it's really good at detecting spam. So yeah, you are responding to spam-like questions. Improve your spam check. I'll probably just prompt it, vibe code it, and it will fix all of this. While that's happening, we can also go and look at what people are doing with Chai, right? That is always more interesting, right? Somebody at our booth built a mini version of Perplexity, where it is using Exa to search. It's a pretty simple agent, by the way. You can ask it something like, I don't know, do a deep research on Google dev blog post on Langbase. I know they published something about us. There was this tattoo artist. I don't know anything about tattoos, by the way. She came to our booth and she was like, a lot of my customers want to know this tattoo versus that tattoo. So I want to build a tattoo agent, and this is what Chai built for her. So basically, she uploaded these two pictures, and it comes up with a bunch of description of what is similar or what not, and she can, obviously vibe code and change a bunch of it, right? There was a therapist at our booth. He had built ADHD chatbots for his patients. There was a coach who had built per player nutrition agents, and he's just uploading their nutrition plans. And he was very happy, like instead of asking me, they are asking that chatbot that is personalized to per player, like what am I supposed to eat right now? I'm feeling hungry, right? So it's a huge unlock for everybody. There was a YouTuber who basically sent this prompt. Chai figured out that we need to go to Google Console and get the YouTube API. And it built a YouTube research agent using YouTube's API, not a third-party API, right? And I asked about my talk from just a couple of days ago, and it brought up this talk, which you should probably definitely go watch, right? There was a CTO of a flight booking startup. She basically wrote this prompt. This, as you can see, is not a really good prompt, right? It's very simple, help users book flights on our website. And she should probably have taught it a little bit more about what the API looks like, and Chai can self-learn very easily, right? And what I want to point out is how sophisticated the agent is that Chai has built here. So get initial info from the user, figure out if there is a tool call required, search for flights, process the conversation. Do we need to do a tool call again? Or is the user asking, like, none of these options are really good? So it will go back to search flight tool call, right? And again, it's a bunch of different things I don't want to go over, but you can see all of this code was written. Like all the tool calls were written, the multi-agent architecture was written, and in a one click it was deployed, right? So my pet peeve in this space is people are not building enough and not deploying enough agents. The moment you start deploying, you start to figure out that, oh, yeah, I can have an agent to do this. And this also applies on me, by the way. I'm an AI company founder, and I've been building for, 5+ years with different LLMs. And I think I had like less than 20 agents about a month ago. Now I have 240, right? I can prove it, right? And people are building so many things. I'm like, Chai works on your mobile. You can basically just go to chai.new and ask it, what would an agent like this look like, right? And you can train it as well. So there was a founder or creator of Zord, the schema library. He was yesterday at Twitter, he was saying, why doesn't anyone build something like, if someone has a GitHub issue on my project, do a RAG of my docs and answer that question for them. And I basically just posted his, a different version of his tweet here. And we ended up together building this very simple agent where it has built the GitHub issue parser and retrieve docs with memory and generate a response and post back to GitHub. Like all of the code is here, right? Finally, I've done things like, I don't know, what is this guy thinking, right? Let me chat with an image. I don't know how many of you actually know, but if you just add a .png after your GitHub URL, it becomes an image, like your github.com/username, right? So that's what's happening here. And then they're like, I don't know, like this is June 11th, right? Almost every other minute, there are people who are building so many agents on our platform, as you can see. I would really encourage you to build something as well. We are trying to build GitHub for AI engineers. Founder of GitHub is actually one of our first investors, right? And yeah, that's pretty much about it. My idea is you cannot build a framework for agents. Agents are just code. You should be able to build whatever you want with agents because they are just code, right? And often, more often than ever, like I'm having conversation with different teams who are ripping apart all the frameworks, all the abstractions they didn't need to build their own. That is what I think I have done my entire life, and I think that is what you should probably do. We are trying to make it really, really easy for you to deploy agents, right? Build it however you want. Build it with whatever service. Like, I just thought of something. There was a Mistral. There was somebody from Mistral who came to our booth, and he was like, can it build with, can it do OCR, right? And I was like, I know you people have a OCR primitive that we don't, right? So we basically just threw in, use Mistral OCR. So build a receipt checker that looks at an image and tells me how many expenses I've had on this trip. And we threw in this piece of code from their documentation, right? And Chai goes ahead and build this agent, which we thought what was super interesting about this was that it didn't do a simple static OCR with Mistral OCR. It basically used GPT-4 vision to do OCR of sorts, and then Mistral OCR and combine both, which is the better way to do it, right? And this was just one-shotted, right? And it built this as an API, and finally it used their example code as to build this example, and you can see it kind of works, right? So you can build very easily any kind of multi-agent workflows without thinking about how to scale it, how to build it, get out of the debate of this framework, of that framework. How about we go ahead and, like, the next time we are here, most of you have actually built and deployed an agent. That would be a fun world to live in, right? Yeah, that's pretty much about me. I'm going to be here, happy to answer any questions.
Thank you. Thank you again for the call, for the talk. So anyone has any questions? Otherwise, I'll go. I always have questions. OK, great.
I'd like to better understand, like, so this code that generated by Chai and you, like, who owns and what license applicable to this code?
Yeah, it's pretty much like GitHub, right? So this is your code. You generated it. It was your prompt. And we are not like a no-code tool. We are a vibe code tool. That's what I like about vibe coding, right? It's practically going to replace no code, which I don't like, right? Here's the code. Do what you will with it. I have built coding agents with it. Like, I have an API agent that understands my project really well and how I build API endpoints really well. And it took me a little bit of prompt engineering to figure that out, but I asked it to build it as a CLI. So I picked that entire file and I run it locally, not on my own company's infrastructure. It just runs locally. And this is a really good experiment. What I would encourage you to do is ask Chai to build a CLI coding agent that can do CRUD, create, read, update, delete files and directories. And take that code, open it up in VS Code, and ask it to write its own README. It will do that. And then ask it to, what should we improve in your code base, which is just one file. And it'll start suggesting things. And you will see it will start editing its own source code file as well. It's pretty magical when you get to explore it, right? So code is all yours. Our hope is that you get to host it with us. We are actually trying to make it really, really easy. But there's no framework here. There's our SDK, definitely. But you can use it however you want, right? Awesome.
How does it go from here to production?
To production as in?
As in, like, what would be the workflow from, like, taking the app from this state to deploying it in production? Like,
oh, everything you see right here is in production, right? Okay. So I asked something silly. I can look at the code that was generated. I can edit all of the code, and then I deploy it. We are the infrastructure company that hosts all of this. So it's already in production. And by the way, a fun little thing that I completely forgot to share. So we are an AI company, right? And we want customers, right? So we have built our best customer. Chai has created more infrastructure on our platform than all of our customers put together. We went from doing 100 million agent runs a month to 517 million agent runs a month in just 1 month. So it has created, all of this is in production, right? 400 million agents have run last month just because of Chai, right? But you, again, like like code is right there, like it's not a framework, so you can use it. However, you can deploy it to AWS if you wanted to. Yeah.
All right, so we'll have one more question here, actually, and then we'll go to the panel, and hopefully we'll have some time in the end for more questions.
Yeah, hi. So I'm wondering what the cognitive architecture of Chai is, and if it's all based on transformers, because it seems like we're trying to automate more and more high-level processes. So that's
yeah. So I think it's not all transformer-based. In fact, our head of ML has done a lot of neurosymbolic research, and I'm a big fan of it, right? So it is mostly transformers. So what she's asking is, how is Chai able to do this, right? It was a silly problem, right? Like, for example, look at Bolt, Perplexity, or Lovable, all of this. These systems can generate front-end code really easily because LLMs know how to build websites, right? LLMs do not know how to build agents, right? At least not now. So we had to train almost 56 different distillations. And you can go to stateofaiagents.com. This is our open research into how people are building agents. We actually studied almost 200 billion tokens. And there's a lot of interesting data here. But we basically figured out this thing. We figured out in which category people were using which provider in what LLM, right? So if you are building for, I don't know, marketing, Google is really good for that, right? Or this or that. This is about 3 months old, so we are going to give it a refresh because we have seen a lot more data now, right? But this was used to distill 56 different models into one that we call Chai. And then we built a bunch of agents around it to build the experience that you see in front of us, right?
Thank you. Thank you so much for your talk. So, so now we are going to change and go to the panel. So I'll invite Cedric. Cedric is going to run the panel. Brooke, Ahmad, everybody. And is everybody going to be sitting down?
Sorry, what?
Is everybody going to be sitting down?
I think so.
Yeah. Okay. So let's do a change of scenario over here, real quick. Thank you. We have more mics.
Thank you.
And one more. Thank you so much.
Going forward a bit. Let's see everyone.
Oh, okay.
I try to not fall.
I am okay.
Well, hello everyone. Wow, what cool demos and interesting talks we've had. So thank you so much for the questions and for the amazing questions you've in the audience you've asked. So now it's a panel. I think we have roughly 20 minutes. We're going to talk a bit more about what your different companies and products. Today it's super exciting because it's super homogeneous. We have Ahmad who's explaining how to build AI agents, and Brooke who's explaining how to evaluate them, and Vamsi who's explaining how once you've built and evaluated them, how you scale them and make sure that they run smoothly in production. So we have the full story tonight. Let's start with a first question for Ahmad, but kind of a question. Before we get into the nitty-gritty details, I can't help, I want to know more. Like, you have code on the NASA Ingenuity Mars helicopter. How the hell have you done that? What's the story behind that?
Yeah, so I'm afraid of heights, right? So I thought...
You're what?
I'm afraid of heights, and I
Okay.
thought I would become an astronaut when I was young, right? Anyway, I'm a web purist, right? I love building websites because I can instantly build and see the feedback of what I'm building, right? And fun fact, my NASA Ingenuity helicopter mission contribution was through GitHub and was for the web interface that they have in the Ingenuity helicopter, right? So it's a small piece of website that is actually running on Mars that I got to contribute to, which was pretty cool, right?
Yeah, it's actually very, very cool. I mean, I think you're the only one here. And maybe
there were like, I think, thousands of people who contributed, so I was a very small part of it.
Well, okay, but I don't think many of us can say that. So, do you have code on Mars?
No code on Mars.
No. See?
In my dreams.
Okay. Okay, serious question now. In a recent talk, you were quite controversial and argued for relying on primitives rather than frameworks when creating AI agents. What exactly do you mean? You talked a bit about it during your presentation earlier, but can you tell us a bit more about what you mean by primitive and explain why it's more effective than using a framework?
Yeah, I think one of the most common issues that we are facing, like we as in me and my company, is messaging, right? So we have built an agent that can build agents. What do you call that, right? And then there is this debate of what is actually a primitive versus a framework, right? So my way of defining it is if you have something that gets in the way of doing what you're trying to do, there are many SDKs that are not frameworks, but they then try to own a bunch of things. Like, for example, OpenAI has this hands-off parameter, which you have no control over, as far as I know, right? Like, you basically tell it, OK, you are an agent, and now you are going to talk to this agent. But if you want to do a bunch of different things between that, you've kind of lost control because you're using somebody's abstraction. So primitives are like building blocks. And the primitives that we build, like for a programming language, primitives are like, JavaScript has object. Everything in JavaScript is an object. Object is one of the best primitives there is, right? But we are building cloud primitives. Cloud primitives are small, possible, repeatable blocks that can be the infrastructure for the agents you are building. It could be a thread, it could be a parser, it could be a chunker, or it could be a combination of things like our memory primitive, which is very much opinionated, by the way. But that doesn't stop you from building your own memory by using other primitives that we have, right? So frameworks are things that would not let you do things that you want to do your own way. Like, I don't want to name names, but LangChain is a pretty famous framework, right? If you're trying
no names, of course.
Yeah. So if you're trying to save a thread, you have to understand like 7 different versions of classes that they have, their abstraction, and then work around that. And the fun thing about LLMs are they are not training those LLMs on these frameworks, right? They are really good at writing pure Python or pure TypeScript, right? So if they can write just about any code, why use an abstraction when you can ask an LLM to just build that abstraction quickly when you are facing that problem, right? So your primitives should be separate enough. They should work without any of the other code or abstraction, and they should work with any of your code and abstraction, right? That's the difference between what is a primitive and what is, I don't know, a framework, right?
Okay, yeah, makes total sense. So it's like when you had frameworks, basically it was an attempt at making it easy to tackle a specific use case, but it was very hard to make it versatile enough to support support multiple of those. So basically, the AI is a new with its ability to combine libraries and low-level primitives to achieve whatever you want. You don't need those frameworks anymore. Basically. Okay. Brooke, in a recent TechCrunch piece, you drew direct parallels between simulating self-driving cars and testing conversational agents. And we were talking a bit about it before, so I'm curious for everyone here. What are 2 hard-won lessons from Waymo, the self-driving car company we're working for, that you found apply most seamlessly to building Coval's AI agent simulations?
Yeah, I think one thing is that agents you can't just test like for this exact thing, I expect this exact output. You really have to look at probabilistic evals, which I think I talked about before. So what is the probability that this event is going to happen across lots of different scenarios? I think the second that we use a lot at Coval is re-simulating from production. So taking real live examples and then re-simulating what your agent would have done in those specific cases. So at Waymo, we would take examples from the road and then re-simulate those in our simulator to see what would the car have done. At Coval, what we do is for a given conversation, we re-simulate what the user said, try to adhere to that dynamically, and then see how your agent would have performed.
Okay, yeah, makes sense. And so your value proposal is super interesting because basically your customers, from the demo I just saw, they just connect your product to whatever agent they have, and it's a plug and play, just go simulate and go test it, basically.
Yeah, exactly. I think we're trying to make it as easy to set up evals really fast so that you can set up a really repeatable process versus having to think like really hard, like building out all of this infrastructure yourself that's basically exactly the same across all of the companies we see. We talk to people all the time who are like, my voice agent is super special and we need very special infrastructure. But they build the same thing. I think where the difference is different metrics and different evals. Like what are you actually testing for is really the differentiator.
Okay, yeah. So just build your agent and delegate the evaluation to an AI, to Coval.
Eval agents.
Okay. So after, thank you, after eval agents, SRE agents. Thank you for the segue. Vamsi. SR, until very recently, I think people have got accustomed to the idea of AI-assisted and vibe coding environment, but until now, it was completely unimaginable to delegate production management to an AI. And only very recently at Build, Microsoft announced the Azure SRE agent. And so we had our discussion for this talk today before that announcement, so even I was not even aware. So what do you think of that announcement? And how does what you do at ReasonOS compare?
Yeah, so a couple of things. In today's customer landscape, we are seeing a lot more, our customers are getting demands from their customers that you need to deploy things with more than one cloud provider, right? Somebody might have a data residency requirement, and you have to use something specific. I know when I worked at Udemy, the first thing that happened when I first joined was we had a deal with Walmart, multiple millions of dollars, and I was talking to my colleague at the time, and Walmart basically told us and said, hey, we're not going to become your customer because you're not using Azure and you're using AWS, right? It would have taken 2 years for somebody to switch over to Azure, right? And the way that we look at it is we're building a framework so that these agents can work across more than one cloud provider and also do it in a compliant way and also create the same environment across more than one cloud provider, right? Using Kubernetes on AWS is very different from using Kubernetes on GCP or Azure, right? How can you create the same exact environment? And how can one production setup be translated to Azure? And so building that abstraction where we become the operating system where people come in and they do their cloud development and validate things very quickly is kind of how we think about SRE. And also unifying a lot of fragmented tooling, right? As engineers, like we're used to using like 100 different tools. And so how can we unify them and create a framework? I'm so sorry, I'm using the word framework. But
you see,
different situation. But how can we unify everything together so that even when you use an agent, you can use Azure's Copilot agent, for example. How can we give it the right context, right? If your infrastructure as code cannot talk to your build, cannot talk to your CI/CD, cannot talk to your code repositories, it's very challenging for you to get a holistic picture of like, what's going on. And so making recommendations with half the picture is very hard. It's hard for humans. It's also hard for AI, right? And so I hope that answered your question.
It does, but I'm curious because when it comes to coding,
Yes.
you have an engineer seated in front of his computer and it generates code, and you can run it, test it, evaluate it. But when it comes to SRE, we're talking about like production systems. So what if your AI like kills the whole thing?
Right, and that's why you need controls in place, right? It's not just about AI. You need the engine that needs to be written in a way where you have a lot more probabilistic workflows in mind before everything is so deterministic. And now with AI, it's very statistical. I always tell my customers when they use a probabilistic system, when they ask me, will this work? An engineer's answer is yes, right? It'll work. You write an if-else statement, it'll do the same thing every time. A lot of with agents, it's like, it'll probably work, right? And so you need to have the engine in place, to have the controls in place to make sure that it doesn't do something it shouldn't be doing.
Okay.
And also prompting it in a way where it won't even consider that is also very, very important.
Okay. So we don't have, we have a few more minutes, but so I would like to switch to a different topic. All of you, actually, maybe with your exception, it's your second, well, is it the same startup, ReasonOS, as the previous one, or did you pivot the startup?
It's different. So before, I was running a company that was doing distributed training of large language models. So heavy provided a framework. Sorry again.
Again.
To
primitive versus framework is going to become the new.
you
started a new war.
But
never use a framework.
So we provided a framework to help companies, research institutions, train these large models and use.
Just in the sake of, I'm sorry to interrupt. I want to focus more on the startup journey.
Yeah.
I guess my question was, and I'm sorry again to interrupt.
Yeah.
More like the three of you are, unless I'm mistaken, quite recent startup founders. 2024, 2024, and 2023 too.
2024.
Okay. Oh, yeah. 4 too. Okay.
Yeah.
So, so very recent. So I guess I'd be interested. Like, could you each of you share a bit about like the journey to founding your own company and how your background influenced it? How did you go from like code on Mars to starting a company? How do you go from self-driving cars to starting a company, etc.? Can you share a bit about your experience?
Yeah, so I'm very technical and I love to build stuff, right? And I've gone and done things. This is my second company, by the way, right? So I've always done whatever was needed to build more, right? And I think like I'm an accidental founder this time, right? I wasn't supposed to build this as a company. I actually actively tried to not build one, right? And then I talked to a bunch of amazing people, finding a founder for this side project. It was growing really well. We had a customer who had, I think, about $18 million in revenue on top of this thing, whatever you call this, right? And that was an on-prem customer. We didn't want an on-prem customer. I didn't want to deal with them early on, right? And then we, I think my entire career was about, well, here's what I built. I'm going to share it with you, right? That's how I ended up sharing and building 100+ small open source packages, right? And then that led to developer relations. Oh, here's how you use this thing that this company does, right? And then what was the next step for me was, well, this is how I built this thing. You don't need an abstraction, right, for this. And then I got so deep into the weeds where like, I had an offer from Anthropic and OpenAI, but I chose to build a company instead of taking that offer.
Oh, wow, okay.
So here we are, right?
So it was like you were building something, you had a big customer, and you did not want to start a company, but you were like, okay, I'm not going to sell, I'm going to go with it instead?
Yes, it was mostly like this. So I actually, funny story, I went back home to attend my younger brother's wedding. So I was not supposed to do anything for a month. That means new projects, right? So, and I found a local agency they were building on top of OpenAI. It was before OpenAI was cool, before there was ChatGPT, right? And there were just no machine learning engineers. It was an 1,800 employee agency of sorts. They used to work for amazing creators who have 400 million followers or whatnot, right? And they had like, I think $70,000 per month in bills with all of what they have built. And I found it an interesting challenge. Like, okay, I'll optimize your infrastructure and see what you folks are doing wrong. And we were able to bring it down to about 10,000. And that was 10,000 a month, right?
Okay.
And we were like, oh, there's a company here. This is bigger than we thought.
Okay.
Right? So that's how I got started. Again, building stuff and accidentally stumbling upon something that's
awesome.
a solution, right?
And Brooke, what about you?
Yeah, I've always wanted to start a company. I think both my parents were entrepreneurs and small business owners. And so I think going through Waymo, I was super excited about all the technical challenge, so I ended up staying probably way longer than I thought. I was like, I'll stay for a year, and then I might start a company. But yeah, and I think seeing everything that was happening in self-driving and like how you could apply those to AI, it seemed really clear that there was something to learn from self-driving there.
Okay. So, so long-time dream, like a childhood dream, you wanted to build your own company?
Yeah.
Okay. Wow. Okay. We can see the excitement in your sight. It's quite obvious. Okay. What
it was
about
actually
you?
when I quit my job. I think a lot of people talk about how their parents were like, "Oh my gosh, you're working on a side project. You're unemployed." My dad was like, "Hell yeah, you're no longer working for the man."
Okay. So last, I think we're running out of time. Yes. So for you.
Yeah, I'll be pretty quick. I've always wanted to start a company, and I've started several. Some of them worked, others didn't. My last one did not, and I was actually burnt out with the whole founder journey, and I did not want to start this company. And what happened was I was talking at a very intimate talk, and someone asked, how did you do engineering at my previous company? How did you get big customers like Amazon? And I just opened up my computer and I said, hey, here's how we do engineering. And it was a tool that I built for myself, right? Did not want anyone else to use it but me initially. And we just got a lot of traction. And so then it just, it became a no-brainer for me to say, hey, like, let's try to turn it into a company and see if it makes sense. And I started talking to people. My first version was actually not very good. But the best indicator that I got was people complained about it, still continue to use it. And so then I was like, yeah, then there's
that's actually a very good indicator. Yeah. Yeah.
And so then I'm like, okay, now I should actually fix it and build it for real that can scale. And so that's kind of how the journey with ReasonOS started.
Okay. Well, thank you very much. I mean, for the insights. Because I know we have a lot of founders and aspiring founders in the audience from the statistics that we have. So I'm sure the discussion we just had was very interesting for many of you. Thank you.
Thanks so much.
Thank you, everybody. So we have until 8:30 to network, eat, talk, And I hope to see you all in the next event. Thank you so much for coming.